Hello again, Year 7 mathematicians, and welcome to your next lesson. And if you'd like to draw a line under the previous work, and today's title is Classify Angles, and pop the date on as well. Just a reminder, you will need a protractor, as we discussed last time, and if you have the availability to do so, please print out the worksheet that comes alongside this. If not, you can measure angles on the screen, and you'll just have to write a little bit more into your exercise book for me, please. So your do now task is to describe the following turns in question 1. Question 2 is just have a go at some real life examples, and then number 3, put on some line segments and identify a couple of angles on there as well for me. You don't need to measure them, but by all means get some practice in for that as well. Okay, so if you pause the video and spend around about 7 or 8 minutes on the do now task for me, please. Okay, got some answers appearing for you here. So north to south, we're going to be doing 180 degrees, a half turn. We don't need to specify direction because it's a half turn. Same as west to east. Oh, sorry, they've just appeared in a slightly awkward order there. But we've got northwest is a quarter turn, which is 90 degrees and it's anti-clockwise. Or you could say a 3/4 turn, 270 degrees clockwise. Same for south to east, same for northwest to southwest in fact, and then the last one's slightly different, northeast to west. Okay, we're doing 3/8 of a turn, because 1/8 of a turn is 45 degrees. We're going to need to move 3 of those. 45 degrees anti-clockwise would take us to north, 45 more northwest, then another 45 to west. That's 135 in total. 3/8 anti-clockwise, or the other way, 5/8, 225 degrees clockwise. Note again how the anti-clockwise plus the clockwise on each of those adds up to be 360 degrees. Okay, and hopefully you've got plenty of real life examples that you can write into your book for us to see as well. And then some line segments, and perhaps for just an example on the angles, you'd say that would be angle DBE. Or you could call it EBD. Remember that angle where it meets, that's the middle letter of the 3. That one would be EAF or FAE. And then one more on here we've gone is FCD or DCF. Okay, so most Catholic churches are adorned with beautiful stained glass windows, and this technique has been used for centuries to depict important events, people and objects. There's a stained glass window on the right there. What maths can you see in this window? List down anything you can see that's mathematical. I want you to have a think about how these could be made. It says that each panel is held together by strips of lead. What maths might the person who made the window need to do before they start? So I want you to write down as much as you can about that, and that will require a little bit of searching, perhaps on Google as well, to see if you can find out exactly what they're made of and how stained glass windows are made. Okay, so for today's lesson, we're going to classify an angle by sight, understand correct notation for right angles, and be able to understand the concept of interior and exterior angles. So, first of all, hopefully we are aware what a right angle is. So that we should know is not a right angle. Neither is that, nor that, and that is not a right angle either. As we've said before in a previous lesson, don't assume, because this is just off being a right angle, that the examiner meant them to be perfect 90 degrees. Okay, to be a right angle, these two lines are going to meet perpendicular. That there is our right angle. For some of you already, you may know how to notate that, but we'll come to that a little bit later on. So now we've gone past, we're going less than 90 degrees. Our right angle is 90 degrees. We're making that angle smaller. That is not a right angle. That one's going to take a little bit of picturing to see on the side, but that is not a right angle either. And again, you can double check these by putting your protractor up against the screen and measuring them. Not a right angle. Not quite a right angle either. And that one there, that is a right angle. Okay. So let's just have a reminder. We put this in a previous slide, but you need to make sure you have this written down in your exercise books for me, please. So those are the various angles we'll be discussing. An acute angle is one that is less than 90 degrees. A right angle is 90 degrees exactly. It cannot be anything else. An obtuse must be larger than 90, but less than 180 degrees. A straight angle, that's just our simple straight line, is 180 degrees. And reflex is anything greater than 180. And then we know that a full turn or full rotation is 360 degrees. So we're going to start identifying and labelling up some angles. So what are the names of these different types of angles? Okay, I'd like you to pause the video and name those four on the screen for me. Okay, so first up we should get is an acute angle. Second one is an obtuse, reflex, and the last one is a right angle. Okay, and is a right angle an acute angle or obtuse angle? It is neither. It's classed as a right angle only. Right angle means it is exactly 90 degrees. To be an acute, it must be less than 90, and to be an obtuse, it must be more than 90, and then less than 180 degrees. Okay, so a few key questions. There are four on the screen there. If you pause the video and have a think about those four there for me. Questions 3 and 4 I particularly like. So again, run through a little example to see what would happen with those and what those terms mean in terms of acute and obtuse. So hopefully we're aware how to illustrate that an angle is 90 degrees. Where the two lines meet, you draw in your little square like that to identify it as a right angle. How do we know which angle we are measuring? That's what we've looked at with our terminology to know with our 3 letters, or perhaps it's been very cleverly highlighted on the picture as well. Oops, sorry. And will turning through 2 acute angles result in turning through an obtuse angle? Okay. So the answer to that is really, it depends. It will be sometimes. It's not always true, and it's not always false. So an acute angle is one that is less than 90, and obtuse is between 90 and 180. If we had acute angles of 60 and 70, add them together, that's 130 degrees, then they would then make an obtuse angle. But you can have an acute angle that's 10 degrees and another one that's 20. Those two together is 30 degrees, and they are still an acute angle. So not necessarily, that is a sometimes for that one. Last one though, will turning through 2 obtuse angles result in turning through a reflex? If we think of obtuse, that is between 90 and 180. Will that result in turning through a reflex? The answer to that one is always. If you pick the smallest obtuse angle you could go for, 91 degrees, if you had 2 of those, add them together, that's 182 degrees. We're now into the realms of a reflex angle, as that is greater than 180. If you went the other end, you had an obtuse angle at 179 degrees, and you had 2 of those, they together would make 358 degrees. Again, that is still a reflex angle, greater than 180 degrees. So, how do we demonstrate there's a right angle without writing 90 next to the angle? We're going to draw our little square on there. Okay, and on this second part here, we've got some lines here that meet nicely to get a triangle. What types of angles are those inside the triangle, and what types of angle are the red ones? So inside there, we would have 3 acute angles. There are 3 angles, and they're all less than 90 degrees. And remember, a triangle, its interior angles, those are the inside ones there that we've highlighted, they will add up to be 180 degrees. The red ones there, what type of angles are those? Now, if we look carefully on the bottom left one there, with the red and the orange, together they would make a straight line, and we know that a straight line adds up to be 180 degrees. Okay, so if the orange one is an acute angle that is interior, it would make sense that the one on the outside we call exterior, and we know then to add together to make 180, if one is less than 90, the other one must be more than 90, so the red ones are obtuse angles. So we call the angles inside a shape interior, the orange ones. Angles located on the outside of the shape are exterior, the red ones. Okay, make sure you've got that written down in your book with that example. use your highlighters, make that very clear, the difference between the interior and the exterior. Your job is on those 4 shapes. And again, if you haven't got the worksheet with you, then you'll just need to do some sketches of those in your book with a pencil and ruler. I'd like you to identify the right angles on those shapes for me using the correct notation. So if you pause it there, make sure that's all copied down and fill in the right angles for me. Okay, these are the ones we should be getting here. I've just gone with the little red squares. Those are the right angles we've got on those. Okay, next up, I've got 3 standard examples that I'd like you to have a look at. And then there's a little bonus 4th part there for me. Okay, so pause the video and you can tell me what type of angles they are and how would you know, and then see if you can circle the acute angles at the bottom. Okay, hopefully you've had a good go at this. So the first one, that is an acute angle. How do you know that? Because it is less than 90 degrees. Okay. Second one, we know that is an obtuse angle because it is larger than 90 degrees, but it is less than 180 degrees. And the bottom left one, that then must be a reflex and it is more than 180 degrees. And for the last bit, circle the acute angles that you can see. As it's highlighted by all those red bits, all of those are acute angles. So all of those 4 are in fact acute angles. They are less than 90 degrees. Okay, so identify the acute angles in this isosceles trapezium. And then below, because I've highlighted a few of those for you to help, find the obtuse angles, any reflex angles there. And then in the polygon, I'd like you to repeat and do the same there for me. So polygon, remember, is poly meaning many, and gon meaning faces, many faces there. Okay, so on the first one, we've got the isosceles trapezium. We're looking there at the acute angles, would be those in red. Obtuse would be the green. And reflex, remember, is anything that's greater than 180 degrees. And those would be our exterior angles. Those would be our exterior angles on that trapezium. Acute angles in the polygon are those interior ones. All of those are acute angles. Reflex angles, we've got those in there, the reflex being more than 180. Could you find any obtuse angles? That's awful drawing from me, but hopefully you can see where the arrows come in. That would be an obtuse angle. Okay, that would be an obtuse. The reflex is greater than 180. That angle there, to make an obtuse angle, there would be greater than 90 and less than 180 degrees. Okay, and last but not least, there's a snowboarder. I want to see how many angles you can find on that snowboarder and see if you can then create some reflex angles from it. And just by seeing an obtuse angle, so one greater than 90 and less than 180, does it help you to identify perhaps where a reflex could be based upon some of the things we said earlier in the lesson? Okay, a little bit more purposeful practice here. Once again, classify the angles as acute, obtuse, reflex, or right angles, and I want you to write why. And when we say why, let's give a definition of what each of those angles are so you can prove you know why you've got those. And then we've got a little bit of an extra thinking question there with Amir. So pause that and make sure you've drawn quick sketches of these in your book if you can't get the worksheet, and then you've given an answer and a reason for each of those, please. Okay, so first up, that is an obtuse angle, more than 90 but less than 180. Reflex, greater than 180. That's our right angle as identified there with the notation. Got another reflex there, greater than 180. Another reflex. And then the last one there would be an acute angle. Oh, spelled that slightly wrong there, apologies, there's an extra T in there. That should just say acute, A-C-U-T-E. Okay. Then Amir says angle ABC is obtuse. Whitney says angle ABC is a reflex angle. Who is correct and why? Now, the difficulty here would be knowing where they are seeing the angle as. It says ABC, but we don't know if in effect we're looking at perhaps the interior or exterior. So for Amir, if he's saying it's obtuse, he's saying greater than 90, less than 180. That could be where Amir is looking. That would be our obtuse angle. That would fit that criteria. Whitney, she might be looking at the other side of it, which is still ABC. That then would be greater than 180 degrees, and that would show that that is a reflex angle. Okay, so in effect there, both would be correct depending on how they looked at it, which is why on questions 1 you tend to highlight exactly which side you're referring to when you want the angle measured. Next up, little copy and complete table. Once again, it is on the worksheet. Apologies if you don't have access to a printer to be able to do that. But if you just get that into your book and sort out how many of those different interior angles you can see in each shape. Okay, so pause the video and fill that table in for me. And when you've done that, you can also repeat for the exterior angles of each shape. Okay, so for shape A, these are our interior angles, how many we should get, and there is for shape C as well, the interior angles. In terms of exterior, on shape A, I believe we should get 5 reflex angles. On shape B, again we will get 5 reflex angles. And then on shape C, I think there will be what looks like 1 acute angle. That'll be the top, the arrowhead there, and 2 reflex, and then what looks like perhaps an obtuse angle there as well. Okay, last bit again, true or false. They're all appeared on the board. As usual, there is 8. I'd like you to pause the video, have a go, and then give yourself a score out of 8. Okay, acute angles are angles which are less than 90 degrees. That is, of course, true. It is possible to get negative angles. No, it isn't there. That is false. It's when perhaps the misconception there would be in terms of direction. We can have 90 degrees clockwise. If we want to go the other direction, we don't go minus 90, we say anti-clockwise. That's why direction is important there. Obtuse, larger than 90 but less than 180. Absolutely. Reflex are greater than 180. True again. Acute angle would have a reflex angle on the other side. That would be true, because an acute is less than 90, so that must mean anything the other side is more than 270 degrees, which has to be a reflex because they're greater than 180. Reflex angle to have an acute angle on the other side. Not necessarily. Okay, so that would be false. Wouldn't happen every time. Okay, if the reflex angle was 300 degrees, then yes, you'd have a 60 degree acute angle, but the reflex could be 200 degrees. That would leave 160 the other side, making it an obtuse angle. Okay. An angle can be a right angle and acute at the same time. No, it can't. A right angle is exactly 90 degrees, and acute angle must be less than 90 degrees. It could be 89.9 degrees and be an acute angle. As soon as it hits 90, it becomes a right angle. Okay. Interior angles are on the outside of a shape. Hopefully you know that one straight away. That is false. Exterior, outside. Interior, inside. Okay, there's a few more little bonus questions on there for you to look through. Make sure you have put all the examples into your book and had a good go at the worksheet. Double check the Word document and the email you received at the start of the week to make sure you're doing the Hegarty clips as well, as that's the bulk of the submitted work. And that then should take you up until half term. So enjoy the long break. It's well deserved, and look forward to catching up with you again after half term with a little bit more work on angles. Take care of yourselves then, Year 7.